So our test is on Thursday. So you need to be preparing for that. But then we also have this project that is due Friday. Okay? And I know I'm giving them to you at the same time. However, I don't feel this project is an insane amount of work to where you're going to feel overwhelmed. Okay? You are going to have the rest of class time today and all of class time tomorrow to work on either the review and or this project. Okay? But what you are going to do is you are going to create a polynomial based on your birth date. Okay? We all have a birth date, right? Okay? Isaac Newton was born January 4th of 1643. So I wrote his birthday as 01/04/1643. And so you all are going to do that with your birthday. Okay? If you are born in the months of January through September, you're going to have a 0 before the number, so 05 for May, 07 for July. And if you were born on the 1st through the 9th, same thing. If you were born on the 1st, you're going to write 01. If you were born on the 8th, you're going to write 08. Everyone should have an 8-digit birthday. Okay? Just write it down right now so you don't forget. Everyone should have an 8-digit birthday. Okay. Now, what you're going to do is you are going to take these and you're going to use them as your zeros. Okay? I would suggest making some of them positive and some of them negative for some variety. But everyone just watch up here. So this was Isaac Newton's birthday. I took each 0 and made it into a factor. So you can see how I took 1 and that was my 0. 4 I made into a -4 for a 0. Here's another 0 of 1. 6 I made into a -6. 4 and then 3 I made into a -3. So I wrote 8 factors down for my 8-digit birthday. And then I rewrote it to look a little bit nicer. So any zeros that I had multiplicity of greater than 1, I grouped those together and squared them. Maybe you even have a cube on one of your factors. Okay? But I would suggest getting some negatives and positives thrown in there, okay, for some variety. Okay? Now, let's see. Here is my polynomial. Now, without my leading coefficient, this is what my polynomial looks like. It's crazy ridiculous. So I chose a leading coefficient that would create my minimums and maximums not to be so crazy. Okay? You can choose a positive leading coefficient. You can choose a negative leading coefficient. But my suggestion to you, put your pencils down for right now, my suggestion to you would be to go into Desmos.com, type in the factors that you have decided on, and play around with what your leading coefficient, what you want it to be, okay? You're going to have to graph this on a graph piece of paper, so you want to be able to fit it onto a piece of paper, okay? All right, so I put my factors into Desmos. I chose a leading coefficient that made it reasonable. Okay, I mean, those are still, I still have like -114 or something like that. But it's at least more doable, okay? So then you have some questions to answer about your polynomial. Okay, what's the degree? What are the maximum and minimum coordinates? What are your x and y intercepts? Please use Desmos. Okay, you can use it on your phone, you can use it on your computer, but watch. Do you see how there are points highlighted, like right here? It's highlighting an x-intercept. I mean, you know the x-intercepts already, but it highlights them. Also, it highlights your minimums and maximums. And when I ask you for minimums and maximums, I am asking for the relative. So in Isaac Newton's birthday polynomial, I have 1, 2, 3, 4, 5, 6, 7, it looks like minimums and maximums. Okay, 2 of my zeros end up being, okay? But you can hover over any of those minimum and maximum points and be able to write down what they are, okay? So you don't actually have to get out your calculator and do, like change the window. Trying to do this on your graphing calculator, you will never have the patience to get your window to what it needs to be, okay? So I would suggest going on Desmos. But it makes it easy for you, okay? It gives you your minimums and maximums, okay? So you have questions to answer on the front. You have questions to answer on the back. Domain and range, increasing and decreasing intervals. 9, 10, and 11, and 12 are questions about what if I did this to your polynomial? What if I did this to your polynomial? How is it going to affect it? Okay? And then a big part of this is actually presenting me with a graph. Okay? So go ahead and turn it to the back side, and at the very bottom of the page is an explanation about the graph. Okay? So everyone is going to get a piece of graph paper. I'll probably, thank you, just give everybody a piece of paper here when I'm done explaining. Okay? Everyone's going to get a graph piece of paper. So you can give me your birthday polynomial, okay? My expectation is that the birthday polynomial fills the page. You're not going to give me a graph piece of paper and your polynomial is right here in the corner. No, fill the page. Be proud of your work, okay? I also don't want this to be done in pencil. So you can, like, preliminarily do it in pencil, but then go over it with either marker or pen. Make it look colorful if you want, okay? Sir Isaac Newton, his favorite color was scarlet, so I made his birthday polynomial red, okay? You need to have a labeled x-axis and a labeled y-axis. Do I count by the same scale? No, you're not going to be able to, okay? But pick a scale to where your minimums and maximums can be graphed on the graph piece of paper, but fill the paper with your polynomial, okay? So notice in that description, I ask that you label your minimums and maximums. Okay, so all mine are labeled. I ask you to label your x and y intercepts. Okay. And then all of the questions about like increasing, decreasing intervals, domain, and range, you may want to go back to those after you have your graph, okay? So I know the explanation of the graph is very last, but you may want to graph your polynomial first and then answer all of the questions so you have that nice graph right in front of you. Okay. What questions can I answer about this project? Yes?
What's the website called?
Desmos.com. So let's see, will it let me write? Nope. DESMOS.com. I love that some of you are writing it down right now. Desmos.com. And what's going to happen? Like when you go to Desmos.com, it's going to look like this. And you just need to say start graphing. And then you can type in your polynomial. So y equals x times x minus 1 times x plus 2, etc., etc. Okay, so type it in like you see it. Okay, also look up here. Do you see this little wrench? Okay, you can change the x-axis and y-axis scale. So over here on Isaac Newton's birthday polynomial, I changed my y-axis until I could see my minimums and maximums, okay? So my scale went from negative 150 to 50, okay? So I played around with my leading coefficient, but then I also changed my y-axis so I could see it. You're going to have to do that. I don't think it's going to be possible for you to squish your minimums and maximums to be in that 10 by 10 grid. So please hit that little tool and change your y-axis so you can see your minimums and maximums. Yes.
For number 2, the second part, the like choosing a day, can we just choose whatever number makes it smaller, or is there like something we have to?
Anything you want. So just pick a leading coefficient that's going to shrink it enough to where your minimums and maximums aren't crazy, ridiculous big. Okay. So I chose 1 over 200. You may find that -1/2 works for you. I don't know. Everybody's polynomial is going to be so different and unique, right? Okay. Chances of people having the same birthday in here are very, very slim. Okay. This polynomial is about you, and yours is going to be different from your neighbors. And even if you have similar zeros just based on, the numeric order of things, you get to make it about you. So you get to make it colorful if you want to. You could add some, some fun with your labels or the title of your graph. But this is about you. I want you to make it how you want it to look. Okay? Other questions? Okay, so I'll give everybody a piece of graph paper from my bin. Notice that on Friday is when we have these due, and they're due at the beginning of the hour because you are going to present your polynomial to your peers. Okay, this is my polynomial. This is my birthday. These are my zeros. Here's what it looks like. Okay, and we're gonna celebrate our polynomials. Okay, you don't want to miss Friday. Okay. Yes.
I'm not going to be here Friday.
Oh, that is so sad. Like all day you're gonna be gone?
All day.
Okay. You and I will talk in a moment.
Okay.
Okay. Other questions? Yes.
How do we go from having our birthday to having a polynomial?
So we take I took 0 and that was my 0. So x was a factor. I took 1 and I made it a 0. So x minus 1 was a factor. And then I decided that this 4 was going to be negative. So I wrote x plus 4 as my factor.
Okay.
So these are your 8 zeros. You choose whether you want them to be positive or negative, and then write their factors. Is that clear? Okay. Other questions? Okay, the remainder of the time, we have about 12 minutes left in this class at least. If you're watching this video, I don't know. The remainder of the time, you're either working on your project or your review. I don't care. I'm going to come around and hand out the graph paper. If you have any specific questions about either the test or the project, then as I come around, ask me at this time. Okay?
I'm not going to be here on Thursday, so is there a time that you want me to take class?